Congratulations, you've all made it through the first of my videos. We are now moving on to descriptive statistics. We're going to talk about scales of measurement, frequency, histograms, descriptive statistics, central tendency, variability, and z-scores. We're going to go over an example of each and how to calculate them. Let's take a look at some misleading statistics. For instance, unemployment is at 15-year lows. Does this tell the whole picture? What is misleading? What could possibly be hidden? Remember, when people report things, they often try to report it to put them in the best light possible. Try to bring some ideas of what might be misleading about this or what is left out to class. Let's take a look at the different types of scales of measurement. We've got nominal, which is categorical. The definition of nominal means small, sort of like minimal. Ordinal means there's an order, which means things go from one to the next, such as freshman, sophomore, junior, senior. But there is no distinct difference between the two of them in that how far one is from the other isn't set, such as the difference between someone who has a bachelor's degree and an associate's or a master's and a PhD. It's not a set defined difference. For instance, with freshman, sophomore, junior, senior, somebody could have 59 credit hours and just be a sophomore, and all of a sudden they have 60 and be a junior. Or they could have 31 hours and be a sophomore, and 89 and still be a junior. Interval is when there is a order, but there is a set difference between things, such as the difference between 100 feet and 99 feet is still the same difference between 5 and 6 feet. That 1 foot stays consistent all the way through. It is always 12 inches. Intervals can go into negatives, whereas ratio, notice there's the O, which can be thought of as 0, and it ends at 0. It can never go less than 0. Interval can be positive and negative. Ratio ends at 0. We're going to go over and have an in-class discussion on how to come up with examples for these. And we're going to come up with quite a few of them together in groups. All right, we're going to talk about some frequency histograms. Now we're going to talk about the difference between histograms and bar graphs. Now histograms, think about it like you're going to go out for the night. If you have a history with somebody, you'll let them touch you. If you are going to a bar where you don't know people, you don't want to be touched. So bar graphs, no touching. Frequency histograms, we're going to talk about the normal distribution, how it looks like a bell curve. And then we're going to talk about positively and negatively skewed, as well as bimodal. Positively skewed means that the mean is pulled to the right side of the distribution, whereas negatively means it's pulled negative. Bimodal means there's two modes. This is an example of a frequency histogram. There's frequencies on the side over here, and there's the IQ score and the breakdown on the bottom. Now notice it counts exactly how many there are, and the bars are touching. A polygon, or specifically a frequency polygon, is just a shape. A polygon is a shape, so this is just counting it and looking at the exact same data we just looked at in terms of a shape instead of bars. This is what a normal distribution looks like. Notice it is symmetrical, and the mean, median, and mode all line up together. Positively skewed distribution, notice the mean is more towards the positive end. If we were to think about this as positive and negative, the mean is pulled more to the positive of the mode, whereas with the negatively skewed, it is more pulled towards the negative side of the mode. Next we have a bimodal distribution, two modes. Alright, let's talk more about descriptive statistics. Most of these should have been covered previously in Stats 1. Central tendency, we got mean, which is the numerical average, median, which is the middle, if we arrange all the scores from highest to lowest, and mode is most frequently occurring. Next, we're going to talk about the different types of variability. We've got range, which is the highest minus the lowest. Variance, which is just the standard deviation squared, and then the standard error of the mean, which we'll start using a bit later. Standard error of mean is used when we have more than one score. And we're going to calculate a z-score. Alright, central tendency, mean, sum, sigma stands for sum, of all the individual scores over n. Median, as we discussed, is the 50th percentile, and mode is the most frequently occurring. Again, just a quick reminder, central tendency. Now we have variability or variation. Variability is to the extent to which scores differ from each other. Variation is a different lexical definition. We have variance and variability. Variance is a more specific form of variability. We talked about range, and we talked about variance and standard deviation. Now, variance and standard deviation specifically talk about how much the scores are spread out around the mean. Z-score is x, which is an individual score, minus the mean, divided by the standard deviation. Here are the formulas, and then we can break these down a little bit more simply into this equation. So we have x, which these are just pulled out numbers, and we do x minus x bar, which is our mean, which we calculated as 3.4. Then we do that again, but instead of just x minus x bar, we do x minus x bar squared. So we have 2 minus 3.4, which gives us negative 1.4. We square it, and that gives us 1.96. And we do this for every single score. We add all of those values up. That'll give us our sums of squared, which equals 7.2. We take that 7.2, and we enter it into the equation where we have sums of squared over n minus 1. Our n was 5, so it becomes over 4. So it's 7.2 divided by 4 equals 1.34. Now, for instance, like we're going to go through in class and have an example on the homework, it's going to be 2 minus 3.4 over 1.34 to give us the z-score for the first top z-score, which will give us negative 1.04. As we can see, it says negative 1.04. And it is okay to end up with a negative number. What it's not okay to get is a negative sums of squares. Because then all of a sudden, if we were to take the average of how much each one is away from the mean, we'd end up with 0. So we need to square them. This is a callback to Stats 1. This is talking about how far away each z-score is. So between negative 1 and 1, there's 68.2%. 2 is 95.4, and 99.7 for 3 standard deviations above and below the mean. To calculate percentile using a z-score, we have to look it up in the back of the book. And we can find out information like a area above, a area beyond, and we can go through and calculate each of these. Homework 1 will be due 1 week after we complete these slides. I look forward to seeing you all in class.